Hello everyone, myself Rahul. I'm starting my YouTube channel, and my channel is called Tech Talk, where I will be talking mostly related to DevOps, related to AWS, Azure, and Google Cloud. I'm a DevOps engineer from last 12 years, and I'm working primarily on AWS as a solution architect. So without a further ado, today's topic is Amazon EKS Auto Mode. So in AWS, everything comes with a same responsibility, as you have seen. So with EKS, AWS was taking responsibilities of control plane, and the data plane was pretty much users' responsibility. So as part of data plane, you not only have to just manage your deployments, but also have to manage several things related to your cluster, such as cluster upgrade. And with the cluster upgrade, you may have seen tons of things goes out of hand, where you have to not only just worry about the add-ons, but also have to worry about which add-on is actually supported and which version and all. With the auto mode, AWS is actually taking that responsibilities for most of the cluster add-ons, if not all, and that basically is going to make it a bit easier. So let's look into what is auto mode, and after that, let's try to create a cluster with auto mode enabled using infrastructure as a code. Today I'm using Terraform and OpenTofu to create a cluster. So let's look into that. Let's deep dive. So like I said, auto mode was recently announced in November 2024 as a part of AWS reInvent. So let's look into the responsibility model. This is what we were having before. So here is the control plane, and this comes under the data plane. So AWS was taking care of the control plane, where the API instances and the etcd instances comes in. We were taking care of all the add-ons which we were using, either to resolve the DNS, which was core DNS, or either to use ingress AWS ALB load balancer, or CNI for EBS drivers for persistence volume and persistence claim, the kube proxy, and several other add-ons actually. We were also managing EC2 instances, if not all. There were Fargate as well, and definitely services as well, which we are deploying. So what does the responsibility model look like right now? So this is the new, as you can see, after auto mode. So now the responsibility model, which is in AWS, is this box, and they are taking care of the control plane like they were before. They are also taking care of some of the managed capabilities like storage, which is your persistence volume, and the claims, what comes in, the load balancing, where you deploy your ingress, and kube proxy, kube DNS, and all sort of things. AWS gives you control to choose what sort of instance would you like to create, whether you are looking into something like Graviton, or whether you are looking something like GPUs, whether you are looking something like heavy workloads for your machine learning or something like that. So that's like a shared responsibility right here. And here is all of your deployments, what you are going to deploy to your Kubernetes cluster. So I have a code which is available in GitHub. There is a link in description. Please have a look. We'll go through all the files over here. But before that, let me take you to the module. Here you can go directly to GitHub. So some people actually prefer to create their own modules, which is actually pretty good. But as part of this demo, we are not creating the module. I will advise you to also use this module, because writing this sort of module will definitely take a whole lot of time for you, and managing this, because Terraform keeps changing a couple of things over the period of time, and you will end up updating your module several times in a year based on the changes. As you can see, this module, the best part to start with is actually if you look into examples. So here are several examples, and the one of the example which we are looking here is EKS Auto Mode, right? So let's look into all the files, like what they are doing. So the first is they are defining a provider. They are using a data resource, which is looking into grabbing all the availability zones, excluding the local zones. And here are some variables, it looks like they are defined, which are further being used with the modules which are defined. Here is the EKS module, and here is the VPC, which is being used to create the EKS cluster. So this is something which I have in this repository. So I have a code space over here. If you do not have, you can just click on an icon here and it will create a code space for you. So let me click on that, and that will open a Visual Studio editor, which is right over here. And it will also give you a terminal right here where you can interact with the command line if you would like to. So the first and the foremost, I have defined this dev container. What's actually a dev container is your code space with come up with pre-built installation of utilities. So as an example, you definitely need AWS CLI, you need Terraform to run Terraform, you need OpenTofu, as we talked about it. And one thing I just want to clear here, I'm going to basically run the Terraform CLI, but if you will do just Tofu CLI as well, which I have as steps and README, let me know if you see any problems and I will try to help you out as well. And kubectl, as we will be interacting with our Kubernetes cluster as well. So those are the commands and sort of utilities what I have defined here, as I will be running Terraform part of this terminal. And let's look into the second section over here. So the first part here, let me go through the vpc.tf. Similar to what we have looked into the upstream project, I have the availability zones and I have the VPC. If you will look into the VPC section, you will find it there can be several kind of subnets what you can create. You will often see private subnet, public subnet, data subnet, which is for your databases, as well as subnets like infra subnet. Just for the simplicity, I'm just using private subnet and the public subnet. I'm keeping my private subnet a little bit large number of IPs here, but my public subnet are not having those many available IPs compared to private, because my nodes will be coming up in a private Kubernetes nodes. I'm enabling the net gateway. It's a single net gateway enabled. As if you're going to do it in a production, I will advise you to set this value to false, which is by default false, I believe. Here we are adding a tag, so public subnet tags. I'm adding ELB, and one is actually equivalent to true. So any load balancer which is going to be internet facing are going to be placed in a public subnet. However, any internal load balancers are going to be placed in the private subnets. So those are the variable tags. You can add more tags if you would like to. So as you see here on line number 12, I'm actually combining these two strings, so local.name and network. So let's look into local.name, which is actually coming from variables.tf. So I have a name here, which is EKS cluster. So this will come up as EKS des cluster des network, because I have the delimiter as hyphen in here. My VPC siders, which also comes from here, and my AZs, I'm actually defining only 2 AZs, but you can define as many as you want. So right in this section, we will get the VPC created. Let's move to the next section where we will create an EKS cluster. And that's part of this file, eks.tf. So we are using an upstream module, and we are specifying a version what we are using. So this is the version, and as you can see right over here, you can find the version what you would like to. So any version which is basically 20 dot something, so it's going to be probably the latest, but not going to be 21 if 21 is going to be released. So similar thing I'm doing, passing the VPC and this private subnet. One thing which I'm doing, which I will advise you should not do when you're running this in production, the cluster endpoint public access, I'm setting it to true. The reason I'm setting it to true, I do not have a VPN setup right now as part of this demo. I hope I will have in future sessions. So I'm setting it to true because I do have to interact to Kube. I do not have the VPN connectivity right now. Another thing here, so how do we know whether it's auto mode enabled or not? or how do we know what all variables we need to actually pass to make it auto enabled? So one of the thing here, you see cluster compute config. If you go to the source module or the upstream module and look into variables.tf as an example, and just pass in this. So configuration block for the cluster compute configuration. Or the better part, what I do is I basically go to main.tf and I just type in, like as an example, auto. So what you can see, the auto mode enable value is basically being set based on this variable, which is cluster compute config.enabled. And that's what we have set up. So cluster compute config.enabled. And this is true. So that means the auto mode enabled is basically getting to true. So cluster mode, auto mode actually supports two sort of node pools. One is the general purpose and one is the system. And I will show you in a minute as well over here. So now we are creating this EKS cluster, and as we have seen, we are creating this VPC. The another thing, for now, I'm just basically commenting this one out, this section out, because I will show you what is the spot instance, and I will also show you what is this IAM also means here. So first is, let's go to EKS Auto Mode directory. Once you clone that repository, and run Terraform init command to initialize the Terraform, which will basically download the modules. Once the Terraform is initialized, I will advise you to run Terraform plan. If you see, there is one variable which I may have to pass as a runtime when I run. If I run Terraform plan directly, it will ask me to enter that, which I can avoid entering and just pass var file equals to variables .tfrs. So that looks right. And what I can do is I can just replace plan with apply. And it's a similar kind of thing, which is good. Looks good to me. And let me take you to AWS console. And let me show you the VPC, which should be coming up pretty quick here. So the VPC is here. The subnets are also coming up here, although the subnets route table might not be completed. Yeah, you can see there is only one route, which is local, and the same thing will be to the private, because my NAT gateway is still getting created. And if we go to EKS, right over here, there is a cluster which is also coming up as a creating state. So it may take around 10 to 15 minutes. So with that, the cluster actually got created. You can see an output over here. Let's look into AWS console and let's see the cluster status is actually active. It took around 10 minutes to create. So right over here, I can see the health is green, status is active, and everything looks good. However, you see, this is like a warning message. The reason this warning is coming because I'm actually using a different SSO role to log into my cluster, which I have not given permissions, because I will be managing my cluster using the role which I used to create the cluster. However, you can add several roles if you would like to, and you can dedicate those roles to per namespace if you would like to as well. So another interesting thing, you will not be seeing a list of add-ons because AWS manages those add-ons for you, like we have seen. And this is where you can see actually the EKS Auto Mode, and you can see it is enabled. Let's look into the settings. We are not going to change anything as we are doing pretty much everything using infrastructure, but this is where I was saying you can define general purpose, or you can define system, or you can actually define both as well at the same time. So you can define the other one as well, which is system. So you can have both defined over there. One thing to note, the one which is general purpose is actually on-demand nodes. So if you are interested to run some of your workloads on cheaper type of nodes, which is on a spot, you can do that, but you need to have other node pool getting created, and this is where AWS is actually talking about that you have a shared responsibility, or you can manage and AWS can manage both the things. So you can create additional type of node pool for your specific workload. You can do taint and toleration and those kind of things as well. So that's what we are going to look as well over here in a couple minutes. So as a cluster got created, let's try to interact with our cluster. So how to interact is, I'm just going to back down a directory here, although it doesn't matter. So I'm going to run AWS EKS update kubeconfig update kubeconfig dash name, and what's my name of the cluster? So EKS cluster auto mode, and I would like to give an alias over here, which is my reason name, US EDW and auto EKS. So okay, so I have to define a reason as well, US is 2. And now the context is actually added to my kubeconfig. As you can see, we can actually also look into kubectl CLI just to look what is the context. Kubectl config get this context. So you can see it's set, and this is the alias what we have given. Here is the cluster ARN. So let me look kubectl get namespace. So yes, we got connected to our cluster, and that's the reason I actually have given this variable over here to that's the reason I have actually defined this variable, so that I can interact with just this terminal to make it simple. So as we have right over here, we have a connectivity. So let's run one more command here, get svc, and you can see this is the cluster IP here. So let's try to do a deployment. So kubectl apply -f, and I have a file here under sample deployment, which is called nginx, which I'm going to deploy. And as you can see, it's created. So let's look into what actually nginx.yaml is doing. It's a kind of deployment where we have 2 replicas and we are deploying nginx latest. So very simple, not doing anything specific. So that's what we are deploying. So far, the node should be created. Right over here, you can see whenever we deployed our first pod, there is a request to the Karpenter, which has created this node right over here. To know more about this node, you can do kubectl describe nodes, and then you can type on the node ID, and you can see what is this node type and all the events associated with the nodes here. So here are the labels, but we have seen that it's AMD64 type, it's C6A large, and those kind of things. And this is coming from the node pool, which is general purpose, what we have defined in our eks.tf file. So it's coming out of that pool, which is general purpose. It's in availability zone A2, and here is the node IP address, and you can see kind of an events history over here, and you can also see what sort of deployments are running. So there is nginx deployment running right over here, which is taking very low CPU and memory. This is actually an overkill. We are paying a lot just running nginx. So let's see how can we actually, to this far, like either general purpose or system won't allow us to basically, create and export instances so far. So how can we do that? So for that, I have this file, which is EKS export, which is export nodepool.tf. So let me uncomment this file and let's go through what actually we are doing. So we are creating an additional node pool, which we are giving a name on spot node pool, which we are giving on spot node pool over here. I'm just adding a label over here, and I'm defining some requirement, like what sort of instances I do need. So I'm basically looking for T3A, extra large and large. I can define micro or medium as well over here. And I'm basically defining a capacity type as a spot. So where did I get all of this information is actually I have kept a document here. So right over here, you can see there are other variables as well, which you can define, and it takes like what is a class, right? Instance category. You can also define the instance family. You can define like what should be the CPU in case you are running some high performance compute, HPCs. You can define those things as well over here. You can define whether it's going to be AMD 64 or ARM. Actually, you can define both the spot and on demand together. For the simplicity, I just have defined the on spot here. So this is So let's do and apply this. In most of the cases, when you're dealing with a spot instance, you have to create a service link role, which does not exist in my account. So I'm basically adding this as well over here, and I will run a Terraform apply. And let me run Terraform apply to add those two new resources, which I have uncommented. So now there are two new resources are going to be added, and that's completed. So let's look into the node pools. Let's run the kubectl CLI get node pools, and you can see just a new one which has got added over here 12 seconds back. Let's describe the node pool, what we have created. And here you can see this is a description of it, and here is the creation timestamp, as you can see. And basically I have also added a taint in here, so I don't want to use spot instances for some of the workloads which are production based or going to be production based. I only would like to use this node pool whenever I specify that request, basically. So as this is ready, and you can see the type ready status unknown, and it is changed to ready now. And if we list again get node pools, the previous one where we ran nginx is actually running one node, but the second one is not running anything. So I have another deployment file which is httpd.yaml. I'm just deploying an Apache here, and what I'm giving is a toleration and a node selector. So this basically matches up the value we have given in this one over here. So it should basically place this httpd on this specific node pool. So let me run kubectl apply -f, and this is going to be sample deployment, and this is going to be EKS Auto Mode sample deployment and httpd.yaml. So now this is created. So let me look into kubectl get deployment. By default it's deployed to the, and here it's 8 seconds. So if I will list the node pools again, so now you see a change in here, which is there is also one node. And let's look into our AWS console, like what's going on. I mean, let's go to EC2 and let's look into the list of instances over here, and let's find. So there is one instance which is just initializing, and we can find the details. So here you can see the lifecycle is a spot instance. However, the previous instance which was created by Karpenter as well was the lifecycle as on demand. So that's the difference in both of those. Like here also you can see if the node pool name is general purpose. However, the other one which we just created, the node pool name is on a spot node pool here. So that's how you can distinguish. And this is definitely cheaper than this one, although I'm running two replicas there as well. So okay, one quick thing, as I have K9s installed, it's easier for me to manage with K9s all the resources. And if I just run K9s, because I have my kube config loaded in this, so it basically recognizes the kube config file. And here on the default namespace, I can see the deployments. I can see both the deployment for my HTTPD, I mean the ports, and I can go to deploy, and I can see the deployment. And I can also go and look into nodes in the same way. So here you can see the nodes 105 seconds back, kind of like 2 minutes back here, and this is like the previous one. So node pool, as we have created the second one, what happens, the node pool, whenever there is a request comes from Karpenter, it basically creates a node claim. And here is both the node claims. As you can see, one is for the general purpose, one is the honest part. So as there are more number of ports or more number of workloads what you're going to be deploy, there will be more number of node claims going to be generated for each different kind of nodes. And that's how Karpenter actually manages. So just to summarize it, we have created EKS cluster. We have created additional node pool for our Spot instances. We tried deploying 2 applications. One is for the general purpose and one is for the Spot instances or custom node pool, I would say. And we have seen our AWS like how the instances are coming up, and you can actually manage. If you have SSM enabled, you can also SSH to that instance as well in case you would have to troubleshoot anything. We have created the VPC, we have created the subnet, we created net gateway and all the necessary networking components. I hope you find the video useful. If yes, please let me know. Thanks a lot for watching. I hope we'll see you soon. Thank you.